Hello everyone, my name is Indrajit Kumar. I am a student at LJMU and currently pursuing Master in Machine Learning and Artificial Intelligence. My student ID is 1038058. Today I will be presenting my final thesis. Topic of my thesis is aspect-based sentiment analysis on IMDB movie review dataset. My thesis supervisor name is Professor Lakshmi Jupudi. So let's have an introduction and background of thesis topic. We will use an IMDB dataset of 50k movie reviews. The dataset contains in two columns, review and sentiment, that helps us to identify whether the review is positive or negative. Why we use aspect-based sentiment? So aspect-based sentiment analysis improves conventional sentiment analysis by automatically assigning sentiments to predetermined groups. So that's aspect-based sentiment. Our goal is to provide a recommendation, a movie on aspect basis by using efficient machine learning model, which is best suited to predict the sentiments, that is output, given a movie reviews, which is input by end user.
So the aim of the aspect-based sentiment analysis on the IMDb user reviews dataset is to identify the sentiment expressed towards different aspects of the movies. Especially, aspect-based sentiment analysis seeks to identify and analyze the sentiment towards different elements of the movie such as acting, plot, soundtracks, special effects, and others. The objective of aspect-based sentiment analysis on the IMDb user reviews dataset is to provide insights into the strength and weakness of different aspects of movies from the perspective of the viewers. This can also help businesses and analytics understand the preference and opinions of the viewers and make a data-driven decision in areas such as marketing, product development, and customer engagement in this movie industry.
So let's see some existing approach such as supervised learning for the aspect-based sentiment analysis. Uh, to do aspect-based sentiment analysis, we have to do in two steps. That one is aspect extraction and other one is a sentiment classification. Aspect extraction is nothing, it's a steps involve identifying and extracting the different aspects or the features that are being discussed in the text. For example, if you were analyzing a customer reviews of a restaurant, you might extract aspects such as the quality of the food and the speed of the service, cleanliness of the restaurant, etc. There are various techniques for the aspect extraction, including rule-based approaches, statistical approaches, or machine learning approaches. So with all these approaches, we can extract the aspects. The other step is sentiment classification. Once you have identified the different aspects of the feature in the text, the next step is to determine the sentiment expressed towards each of those aspects. In, in this involves classifying the sentiment of either positive, negative, neutral, all this. So there are various techniques for sentiment classification, including rule-based classifications are there, rule-based approaches are there, lexicon-based approaches are there, machine learning approaches are there. So let's see one by one how one by one about existing sentiment analysis approaches. Sentiment analysis can be classified on two approaches such as machine learning approach or lexicon based approach. So machine learning can be further classified in a supervised or and unsupervised, whereas lexicon based approach are classified in two broader category, that is dictionary based approach and the corpus based approach. And the sentiment analysis can be achieved by different supervised learning approaches such as logistic regression, naive Bayes, support vector machine, random forest classifier, etc. Several studies have been conducted on aspect-based sentiment analysis, and this slide summarizes some of the key findings and approaches used in this field. First one is the aspect extraction. This is the first step in the aspect-based sentiment analysis, where the aim is to identify and extract the aspects or features that are being discussed in the text. Various techniques have been used for aspect extractions, such as rule-based methods, statistical models, and the deep learning-based models. Rule-based methods are often used for the simpler tasks such as extracting aspects from movie reviews where the aspects are predefined. Statistical and deep learning-based methods are more effective in identifying new aspects in more complex tasks, such as extracting aspects from the reviews dataset. The next is the sentiment classification. Once the aspects have been identified, the next step is to classify the sentiment expressed towards each word. So various approaches have been used for the sentiment classification. like lexicon-based methods, machine learning-based methods, and the deep learning-based methods. Lexicon-based methods rely on the predefined sentiment lexicons to classify the sentiment of the text. Machine learning-based methods used pre-labeled data to train the model to classify the sentiment of given text. And the deep learning-based models or methods such as a RNN or the CNN has shown also have shown a promising result in the sentiment classification. The third one is a opinion aggregation. So opinion aggregation is a process of combining the sentiment of a different aspects to generate an overall sentiment score for a review. So various techniques for the opinion aggregation are simple averaging, weighted averaging, and the graph-based methods. Simple averaging is the most basic technique where the sentiment scores of all aspects are averaged to generate an overall sentiment scores, and weighted averaging assigns different weight to different aspects based on their importance. And the third one in opinion aggregation is graph-based methods. This used to graph to represent the relationship between the different aspects of their sentiment scores and use graph algorithms to generate an overall sentiment scores. The fourth one is a domain adaptation. So it is a process of adapting a aspect-based sentiment analysis model to a new domain. So various techniques are available for the domain adaptation, such as transfer learning, multitask learning, and a cross-domain sentiment analysis. Transfer learning is a pre-trained model in a source domain and fine-tune it on the target domain. Multitask learning involves training a model to perform multitasks, such as a sentiment analysis as well as aspect extraction, both simultaneously. And the third one, the last one, the cross-domain sentiment analysis involves using labeled data from the different domains to train the model. So aspect-based sentiment analysis is rapidly growing field with many promising applications. Future research we should be focused on the improving their accuracy of the aspects extraction and the sentiment classification. Yeah. So that's a okay. That's a challenging of the domain adaptation. So let's see the current progress what we have with respect to aspect-based sentiment analysis on IMDb dataset for user reviews. So so here we have I tried to build a sentiment analyzer. So let's see the dataset. What we are using is IMDb dataset having 50K movie reviews for natural language processing or text analytics. This is a dataset for the Barry sentiment classification containing substantially more data than previously benchmarked datasets. We provide a set of 25,000 highly polar movies reviews for training and 25,000 for testing. So predict the number of positive and the negative reviews using each classification or deep learning algorithms. So you will see in detail. So let's see the most frequent use of word count used in the review, left hand side, and the right hand side we can see the positive and negative sentiments in the movie reviews. So by looking this, we can conclude that the dataset is not skewed in any way. There are an equal number of meanings for reviews of both polarities, included in the dataset. The collection includes terms and HTML syntaxes that are unnecessary or redundant. The dataset contains an adequate amount of punctuation and stop words, and all of which are distributed uniformly. So this indicates that we have a lot of work to do in terms of cleaning. So to achieve clean data, so we have some data processing. So that is a cleaning up the text, removing the links, take out all the special characters, removing of emojis, take out all the punctuation, then remove all unnecessary stop words and HTML, take out all the infrequently used words, contraction expansions, complete conversion to the lower case, lemmatization, tokenization. All these are the some data processing, cleaning and processing work. Actually, that's a primary work we have to do it. You can see that you can see the comment also. The comment is a lot of work required to clean by looking this comment. We can see. So let's proceed to the next slide. We can see the unigrams and the bigrams of the positive reviews. Here we will use a bag of words since we care about the frequency of the words in the text reviews. However, the order of the words is irrelevant. Two common ways
to represent bag of words are tokenizer and the term TF-IDF, that is term frequency, inverse document frequency. So we want to identify unique representative words for the positive reviews and the negative reviews. So we will choose the TI-FDF. So to turn text data into the numerical vector with a TI-DF, and we found these are the coefficients corresponding to each words. So here also same approach to get the negative unigrams and bigram words. Let's go ahead.
I will show you the word and phrases with their opinion values and their categorization, how it came. This is an example of a strong positive and strong negative opinion bearing phrases, along with the representative value ratings are provided in this table. There is a clear, if you see, there is a clear distinction between the phrase words on adjective and those based on the nouns. So this is an example of opinion phrase that has a value of less than 60%, 60%, and is therefore not considered to have a strong positive connection. Has also been displayed here. And this is the feature engineering on the coefficient basis aspects as a feature name. So you can see now word embeddings are generally speaking a technique in the field of NLP. By using a word embedding, we found that these words are highly positive biased and negative biased. It explains a technique in which words are represented as a dense vector in the space with a high dimension that contains many. Each word occupies a distinct place in the vector space. During training, this positions is learned from the text and based on the surrounding text. These are the some most occurring words which I found in the feature engineering process as sentiment aspects. So let's see now. Now let's have a look on some machine learning and deep learning approaches for making the sentiment analyzer. So use of machine learning. So I started from the scratch to build a model by using well-known machine learning approaches as a logistic regression or the random forest classification, naive bias, SVM. So these are the common practices. I started with that, and then going forward to deep learning or neural network such as LSTM, BiLSTM, convolutional neural network, and combined LSTM CNN approaches. So each one have gave me a good result with some of the pros and cons. So so, so let's see some of the pre-trained transformers what I have used to achieve good accuracy. A pre-trained transformer is nothing. It refers to a type of a deep learning model that has been trained on a large amount of data using a neural network architecture, which is known as a transformer. The transformer model is particularly well suited for the NLP or natural language processing task because it can capture long range dependencies and contextual information in the text. So by leveraging the knowledge of knowledge and patterns learned during the pre-training phase, fine-tuning a pre-trained transformer on a sentiment analysis task can significantly reduce the amount of labeled data required to achieve high accuracy. So that is a reason to go ahead with the pre-trained. So the first pre-trained model Glove, what I have used is an unsupervised learning algorithm for generating a vector representation. The Glove full form is global vectors for the word representation. So this is also known as embeddings of the word in a high dimensional space. The key idea behind the Glove is to create a word-word co-occurrence matrix, which captures the frequency of how often a given pair of words appears together in a corpus. Glove then factorized this co-occurrence matrix to obtain a lower dimensional representation of the words in a corpus. The resulting vector can be used to represent the meaning of the words in a way that are useful for various language processing tasks as sentiment analysis. So Glove has been shown to me effective method for generating word embedding, outperforming other popular methods such as word to vector. As I said, this generates a high dimensional vectors for each word, which can be capture semantic meaning and relationship between the words. And like word to vector, Glove is also a log bilinear language model and fine-tuned to give input of 300 dimensional vectors from each content, followed by a sigmoid activation. Bandy cross entropy will be used as a loss measure for the Bandy classification, and Adam is used for the optimization. So with this we I am able to achieve a good accuracy of the around 90% in on a training data set, and in a less time. So that is let's go ahead with LSTM classifier. LSTM classifier is nothing. It's a long short-term memory classifier, and is it one of the type of recurrent neural network that is capable of handling a long-term dependency in a sequential data. So LSTM network are particularly well suited for the processing of the text data, where words often have complex and variable relationships between or between the words or with one another. So an LSTM classifier consists of one or more LSTM layers followed by one or more fully connected or dense layer, which are used to output a probability distribution over the possible classes. The LSTM layers are responsible for processing a sequential input and the capturing long-term dependencies. So while a regular LSTM can be access past information, but a bi-LSTM can access both past as well as future information at the same time. So here I have used bidirectional LSTM is utilized to utilize so knowledge content in both the past and the future can be achieved. And in a bi-LSTM, the input sequence is processed in two directions simultaneously, with one of the LSTM layer processing the sequence in the forward direction and another LSTM layer processing the sequence of the backward direction. The output of both layers are connected to produce a final output. So that's the way by LSTM works. The forward LSTM process the sequence from the beginning to the end, and the backward LSTM process the sequence from end to the beginning. Hence, it is most suited to solve sentiment analysis task. But with this, what I was able to achieve is a lower test accuracy of 81% and a higher test loss of 41%. So that we can see on the graph as well. So now our next transformer is BERT, which is a very most common transformer. It has two important aspects. One is MLM and other one is NSP. MLM means a master language model, and NSP is the next sentence prediction. So these two techniques, these two aspects of the BERTs is making our problem to solve in easy way. So BERT is a trained on a large amount of text data to learn the representation of words and phrases that capture their meaning and relationships. BERT takes into account both the left and the right context of each word or token in a sentence during the training, allowing it to capture even more complex relationship between the word and phrases. So and the BERT is fully based on the transformer architecture, which is typically a neural network that has been shown to a particularly effective or effective for the processing of sequential data, so like a text data. BERT consists of a multi-layer bidirectional transformer encoder, which is a pre-trained on a large corpus of the text data using a masked language modeling and masked language modeling objective and the next sentence prediction objective. So the masked language model objective involves masking random tokens in the sentence and training the model to predict the original token based on on its context. The NSP objective involves predicting whether the two sentences in a pair are consecutive or not. So BERT took the longest to train, um, but what I have achieved a test accuracy of 88% and test loss of 61%, which are both quite good. But yeah, we'll see on the next approach, and then we'll conclude it about which one I prefer in my whole journey. The next transformer what I have used is XLNet. XLNet is also a well-known transformer. It's calculating the likelihood of the word in a sentence based on all the possible permutations. So XLNet is a trained on a large amount of text data to learn representation of the word and phrase that captures their meaning and relationship, as BERT also doing. What sets XLNet apart from other language model is its use of an auto regressive mechanism combined with a permutation based on training approach. So this is a bit tweak actually what XLNet perform other than other how other models are performing. So that's the difference. So unlike previous models such as BERT, which rely on the left to right or masked language modeling approach, XLNet takes into account all possible permutation of the input sequence during the training. So that's the difference actually. So allowing it to capture even more complex relationship between the word and phrases. So XLNet also makes use of a technique called relative positional encoding, which allows the model to better handle long range dependencies between the tokens in the sequence. With XLNet, I achieved a higher test accuracy, near about 89%, and the lowest test loss was around 50%. So these are the four pre-trained model what I have used to achieve a sentiment analysis on the expect basis, and found found here the result. In all my approaches, Globe pre-trained model works excellent in less training time, as I can conclude also by looking this table. So let's see in detail. So BERT took the longest to train, but achieved a test accuracy of 88%, and the test loss of 61%, which are both quite good. So and Accelnet took ever longer to train than BERT, but achieved a higher test accuracy of 89% and a lower test loss of 50%, suggesting that it may be more effective model for this task. Uh, yeah. So the next is LSTM took much less time to train than either BERT or Accelnet, but achieved a lower test accuracy of 81% and higher test loss of 41%, indicating that it may not be an effective model for this task as the other two. But Glove, which is not a model, but rather than a set of pre-trained word embedding, was much faster to train than any of the other models and achieved a very high test accuracy of 90% and low test loss of 27%, suggesting that it may be very effective approach for this sentiment analysis task. So here are some future recommendations. Transformer-based models with auxiliary tasks, multitask learning model, hierarchical attention-based model, and the robot. So all these approaches to the natural language processing and that have shown a promising in improving the performance of the various NLP tasks. So transformer-based models with auxiliary tasks are designed to learn multiple tasks simultaneously by adding auxiliary objectives during the pre-training or a fine-tuning. For example, a model could be trained to predict not only the next word in a sentence, but also the sentiment of the sentence. The next one is a multitask learning model are similar to above one in that they also learn multiple tasks simultaneously, but they do so by sharing the same model parameters across all the tasks. This approach can lead to improve generalization and better performance on each task. The third one is a hierarchical attention-based model. Hierarchical attention-based model are use a multi-level attention mechanism to capture the dependencies between the different parts of the documents. This approach is particularly useful for tasks that requires a more aspect understanding of the context. And the fourth one is a Robota. So Robota incorporates a number of optimization to pre-training process, including increasing the amount of training data and removing certain pre-training objectives. So which has led to improve performance on a wide range of NLP tasks.
So in this slide, we will see the conclusion. So aspect-based sentiment analysis is challenging in the NLP task that involves identifying the sentiment expressed towards the different aspects of the movie reviews data. And the deep learning models such as BERT, XLNet, BioLSTM, and Globe has shown a promising result in the solving task. In this study, we evaluated the performance of these four models on a IMDB user reviews dataset in terms of accuracy, precision, recall, and F1 score. The performance of these models may vary depending on the specific dataset and the task. And future work can explore on other datasets and fine-tuning strategies to further improve the performance of these models in aspect-based sentiment analysis task.
Thank you. Thank you very much. Have a nice day. Bye.